Guys, tell us in the comment box. Now, should we start?
Datta, can we start?
I think we should start. There are much of audience saying us to start, so we can start.
Shailendra present? Is he going to wanna give introduction? So let's start by myself. So welcome everybody to the new season of welcome to the new season of the FOSS Files Ops Unleashed. In this season, we are covering all the major DevOps topics. Uh, so are you guys excited?
Yep.
Yeah, let's go. So the first episode we are going to have is intro to the virtual realm. So what comes into your mind by hearing the virtual realm?
So before starting, just I wanted one clearance, Tushar and Aradhya. As we can see, everyone can turn on their mics as per their wish. So can audience also give answers verbally, or should we just use chat for it? Hello, Tushar, Aradhya.
I think we should put our questions in the chat box, but if they ask any questions, then we can answer by turning on our mics, okay?
Yes, that's what I was also thinking, that answers can be given through turning the mics on. So, all the audience, you can turn on your mics if you want to answer whenever you want to answer. But questions, if you have any questions, just put it in chat box. And if Tushar and Aradhya are there, then we can start, or else if
So
they have
without
any.
any further delay, we continue with our session. So I welcome you guys, Harsh and Vaishnavi, our today's podcast stageholders. And now the spotlight is on you guys. Yeah, you can start.
Should I share my screen?
Yeah, you can share.
Is my screen visible? And am I audible?
Yes, it's visible and you're audible.
Okay, so as we all know that we have successfully conducted last two seasons of our podcast, in which we have learned about different languages as well as the database chronicles. So here we are to start with our third series, that is Ops Unleashed, and today we are here for the first episode, that is the virtual realm. So the topics we will be covering today are going to be DevOps. In this whole season, we are going to talk about DevOps and the technologies related to DevOps. So let us first see what actually is DevOps. The second topic that we will be covering is virtualization. Then we will look out for Podman, which is a alternative for Docker. And lastly, we will be seeing about Vagrant. Okay, so I think most of you might have heard about posts like DevOps engineer in the companies. So, do you have any idea about what is the work that they do or what does DevOps mean? Anybody? You can turn on your mics and answer. Work after developers do their job, okay? I think everybody from you will be having their own interpretation of what DevOps is. There are still people typing. Should I continue further? Okay, so just let me break down this term, that is DevOps, for you. So DevOps basically consists of two terms, that is which stands for development, and Ops, that stands for the operations. So basically whenever you're building your project, your team is generally categorized into two teams. The first one is the development team and the other is the operational team. So what are the tasks related to this team is the first question. So development team is something that plans according to the project, what are the requirements and what are the outputs expected by your client throughout the project. And the operational team is something that deploys your projects, it manages your project and also kind of monitors your project. And if there is any feedback that is given to the development team. So obviously both these teams have to work in sync with each other and have to go hand in hand. And DevOps follows the procedure of continuous integration and continuous deployment. So what used to happen earlier was that whenever you were assigned on a new project, what they used to do is that they used to divide the project into different stages, and they would move to the another stage only when the first stage was complete. So, for example, when you get a project, you will first completely analyze the project, that what are the requirements of the client and what outcomes do they expect from the project. Do you have the systems compatible to the project, etc. So when all these requirements are completely defined, these requirements were being sent further to the design team, which used to completely design the system for the project. So after the design is completed, it is sent to the developers so that they can code your project. And when the code is completed, means your project is like halfly complete, and this coded project was sent to the testers. So these testers worked, tried different use cases, test cases, and tried to check the durability of your system. And when your system was considered to be fit and fine, this your system is being deployed and then managed. So if I find any bug at the end of the process, so I would have to start over completely again from the analysis. I have to check where did I go wrong and completely analyze it again design it, code it, test it, and again deploy it. So I think this will require the whole process. We have to start from the first. So this is requiring a lot of time, and it is very time consuming. So what does DevOps do is that it divides project into small parts, and continuously these projects are being built and they are integrated with the existing completed parts, and they are being deployed. So as you can see, the DevOps symbol is like an infinity, that because the loops goes on continuously until it is the end of your project. The development team completely plans your project, it codes it, it builds the whole system, and it also tests the system for its durability. Whereas the operational team releases your project, it deploys your project, and also the operations, and it is continuously monitoring your project. So DevOps actually helps in increase the collaboration as well as communication between both these teams. And it also shortens the deployment and development life cycle. And because of continuous integration and continuous deployment, the frequency of this deployment is also increased, and also it enhances the stability as well as durability of your application. And that is why DevOps approach is being very popular nowadays in the IT industry. So the next thing is virtualization. I think most of you obviously might have heard about this. So what do you think when you hear the term virtualization? Anybody? It is not physically present. Dividing the computing resources into virtual machines. Yes, you are kind of close people. So basically, what virtualization? Anybody else want to reply? Okay, let me start. So basically, what is virtualization is that we basically create virtual copies of anything which we require. Like it might be your computer hardware, it might be your storage system or your network resources, which are not physically present, but we are creating it virtually. So, like take an example. If there are various businesses running, if you want to create offices for a lot of businesses, and if you will go on creating separate building for offices of each and every company, then it will obviously require a lot of space, lot of cost, etc. And this might not be feasible. But what if you create a whole building and you assign every floor to each company, so that they remain isolated, they can also do their own work, as well as they can use the common utilities, like maybe it be steps, the fire extinguishers, the elevators. These are something of some common resources that are being used by these companies. So obviously this approach is going to save your space, as well as it is going to save your cost, etc. So like if you are working in a company and if your project has a lot of requirements, and all these different requirements kind of require different operating systems for your compatible for their compatibility. So if you are going, it is not physical, it is not very easy, or it's possible for you to have different physical machines for different operating system, because the data management and resource management between this communication between these machines is going to be very tough. So what if I tell you that you can use all this operating system in your single computer? So that is what virtualization does. So basically, we use a software layer to create a virtual layer over the hardware, which allows us to use the hardware very efficiently you can see in the architecture also of a physical server. We all know that operating system is basically an interface between your hardware and your application softwares or your users. This is the traditional architecture of the computer that we follow. But in virtualization, what we are doing is that we are creating and we are adding an additional layer which is called as virtualization layer, on which we can create different virtual machines and applications. So this virtualization basically mainly consists of hypervisor. This is the most important software, and hypervisor is the software which makes the virtualization feasible. Hypervisors allows the elements of the system, like be it your memory or your storage. This can be distributed among the various virtual machines that you are creating. So on the host hardware, you are creating a software layer which is called as hypervisor, and above hypervisor you can create as many as virtual machines that you require. Now all these virtual machines are isolated from each other and they perform their own functions. So suppose you have your laptop in which you have Windows operating system. So you can also use be it Ubuntu, be it Kali, be it Mac OS. You can use any kind of operating system in your computer. So all these virtual machines that you are using will be basically using the same hardware of your host machine. So what is hypervisor is the most important question here. So hypervisor is nothing but it is a kind of virtual machine manager. So all these virtual machines that you are creating, it kind of coordinates between these virtual machines and it manages them. So it is a software that creates and runs that virtual machine. As we know that virtualization is possible only and only because of hypervisor, and it allows your host computer to support multiple guest virtual machines by virtually sharing its resources. So what hypervisor does is that it basically creates a layer over your hardware so that you can use different virtual machines on your computer. So does anybody of you have any name, can you name any technology if which works on the concept of virtualization? Yeah, I can see cloud here, which is right. Virtual box is right. So let us just consider the example of cloud. So earlier, what used to happen is that every company they used to have their own servers to deploy their projects. We all know that if you want to make anything visible to the users, you will obviously have to deploy your app or website, and also have a database to store all the data related to your application. So obviously we use cloud technology for this. So before, what used to happen was that every company used to have its own server, which it used to deploy its applications and used to store its data. But the thing was that we have to be able to guess our capacity. If I am developing something which is going to be widely used, then obviously I'm going to require a large number of servers. Also the capacity of each of these servers has to be very high. But if I'm creating a simple app which I know is not going to be used very well known, or it's not very much used, then obviously I am going to go for servers that do not require very high facilities, or it does not require a lot of storage. But if on a certain day there are many so this is the main problem. So the first thing is that you're not able to completely predict what is your audience, according to which you will decide the server that you want to use. The second thing is that if you use a server with a large data sets and your application is not very much used by the users, so most of the resources of your servers are going to be underutilized, and you are going to be uselessly paying for that, because we know that cloud is a service that works on the basis of pay as you use. So if you are using the whole server, but you are paying for the whole server, but actually you are just using a fraction of the server, then this is not going to be cost efficient for you. And the third thing and the most important thing is that problem is of scaling. So if on a certain day there are many people, like my app got just famous and there are many people trying to access to it, and now my database or my server is not able to respond to it. It is not possible for me to physically set up another server so that they will be able to respond to the requests, so many requests that are coming on my application. So these three problems, that is underutilization of resources, overly paying for the resources that you're not using, and scaling, these were the main problems. But these problems were solved by virtualization that we use today. The virtualization, the revolution that it brought was, we can create different virtual machines, and whenever virtual machine is required, if we need any new instance of virtual machine, then we can create, like if I put a command that if my application exceeds certain users, then I want an extra virtual machine too. So this both together can handle all the requests, and if I at a certain point there are many less users on my applications, then I can scale down the virtual machine count too. So is everybody clear with the concept of hypervisor and virtual machine? What is virtualization and DevOps? You can answer with your mics.
Yes, clear.
Yes. So this hypervisor is basically of two types. The first one is the hosted architecture, and the second one is the bare metal architecture. So you can see the difference in the diagram itself, that the hypervisor in the hosted architecture is the software installed on your host operating system, whereas in bare metal architecture the hypervisor has direct access to your hardware. These are the two types of hypervisors, and the examples for respective hypervisors is Oracle VirtualBox is kind of a uses kind of hosted architecture, whereas VMware ESXi uses bare metal architecture. So as we have seen, bare metal hypervisor runs directly on the host hardware. It has direct access to the hardware and it manages the operating system. Basically, without the operating system, it is the interface between your hardware and the virtual machines that you have created. And hosted hypervisor, the software is installed on the operating system. So basically, if the hypervisor wants to use the hardware resources, it will first have to make a call to the operating system, and then the operating system will make the calls to the hardware. So the problem with hosted hypervisor is that the latency of your tasks is going to increase. The response time is going to increase because there is an additional layer of operating system. Whereas in bare metal architecture, this operating system layer is absent and your hypervisor has direct access to your hardware. But the compromise in bare metal hypervisor is that you are going to compromise in your security, as there is no operating system host operating system present on your machine, which is going to monitor that. So lastly, if we see the differences between the physical server and the virtualization, they are quite common, that in physical server, you're not sharing resources between multiple users. One desktop is going to have its resources, which is going to be used only by one user, whereas in virtualization, all these resources are shared by multiple users, as you have multiple guest operating systems or multiple guest virtual machines on your computer. So this will be having different users which are basically using the same resources of your host PC. In physical server, the hardware is used directly by the operating system, whereas in virtualization, we have a layer which is software layer, which is known as the hypervisor, which manages all these virtualized resources. In physical server, we have a physical memory, hard drives, processor, connections, and operating system. Whereas in virtualization is software based that emulates all the functions of the server. This layer, which is hypervisor, that's the most important layer, emulates all the functions of the physical server. And in physical server, we can use only one operating system at a single point of time, whereas in virtualization, we can have independent OS, which are like we can have a category of independent OS which are used on the top of the hypervisor, and simultaneously you can get access to different operating system according to your wish, as well as the data management between this operating system and resource allocation between these operating systems becomes very easier, as all these operating systems are running on a single host machine. Are we clear with this?
Yes.
Okay, so the next session is going to be continued by Harsh. Other than cloud, can you give me any other example of virtualization? Yes, doctor is right.
Hello everyone, am I audible? Okay, so I had some technical issues, so I am joining from this PC. Okay, so now up till now we have completed virtualization. So
The next on the slide, you can see what is containerization. Does anyone have an idea what is containerization? Put it in the chat box. Collecting everything together that we need is. Package of every essential element of a project. Yes. Bundling together all the things needed to run an application. Yes, yes. So, Vaishnavi,
The screen is visible, right?
yes, please move to the next slide.
Huh.
Okay, so everyone must be aware of this very famous meme, right? Like, it works on my computer, but okay, so this is where the term containerization came into existence. Like everyone must have an like instance of theirs, like when the code is running on their PC, but when we try to deploy it on someone or use it on someone else's PC, the code is not like it gives some errors on any other thing. So this is where the term containerization came into existence. So what we're doing containerization is next slide, Vaishnavi. Okay, so in containerization, we make containers. So what does a container mean? A container means like whatever packages or the dependencies which will be required for our project, we put them together into a single container. And wherever we like deploy that container, we will be able to use that particular dependencies, and we will be able to run our project smoothly without any further errors. So this is what we mean by containers. Like we package everything into a single container and then deploy it somewhere else, somewhere so that we can use it further. Next slide. And this is what we mean by containerization. Like containerization is a process that bundles an application with all the files and libraries it needs to run on any infrastructure. It is an operating system level virtualization. Like containers are set to share the host system's kernel with other containers. Like now we have got the term like containerization. Like so now we have got two terms, virtualization and containerization. Can someone tell me the difference of containerization and virtualization? What do you understand by the two terms, virtualization and containerization? And what is the difference between them? Put it in the chat box. Okay, so I'll explain you with an example. Like, let's suppose there's a library, and in a library, we have private rooms for study. Like, there is a private room for every individual, and they can go there inside and study, and they have their different utilities available in that private room. So this is an example of virtualization, like where each individual is having a separate private room, and this private room can be called as a virtual machine. And if we take an example of containerization, so similarly in libraries there can be a shared area where everyone can you come and use the resources available in that particular area without any like private rooms. So this is an example of shared environment, which is which is on the basis of containerization. So this is what is the difference between the containerization and virtualization. So did you guys get it?
Yes.
Yeah.
So next slide. Okay, so this is an GIF where you can like understand what is containerization. Like we are packaging everything into a container and then deploying it so that there are no issues like render issues once it is deployed. Okay, next slide. Okay, so now like as we have got the term containerization, so then comes how to containerize like our projects into a container and how to use containers. So there comes this term podman. So has anyone heard of podman? Like anything you know about podman, put it in the chat box if you know, or just say no if you don't know.
Uh, I personally don't know about the Podman.
Okay. Okay, so like we talked about containerization. So there has to be a platform where we must be able to create these containers, manage them, and so am I audible? Yes. Podman is a so starting with Podman. Podman is an open source tool for developing, managing, and running containers on your Linux systems. So and it was released in September 27 by Red Hat. And the primary language which was used to write Podman was Go. So in one of our previous sessions, we had covered Go. So you might be familiar with that thing, right? Okay, so next slide. Next slide. Okay, so how Podman works and what is actually Podman. Like we have discussed what is Podman, like it is used to manage and manage the containers, different containers. So, but how does it actually works? Like the first thing, it is like it is a process-based approach. Like it manages the containers as individual processes, eliminating the need for the central daemon. So, what does this thing mean? Is like when we use Docker, we are dependent on a centralized process. Uh, Centralized process which is responsible for creating and managing the different containers which we are creating. So but in Podman isn't like that. We call Podman daemonless because it doesn't depend on any background process for creating or managing the containers, but it itself uses its own container runtime the to create and manage the containers, and it uses the runc uh, container runtime. So I just now mentioned container runtime. Runc uses the runc container runtime. But what actually is container runtime? Container runtime is nothing but it is a method which is used to manage the containers, different containers which are available on that particular platform. So the next is command line interface. The Podman allows us to interact with the containers via the command line. So this is how Podman works basically. Like it is a daemonless process. It uses runc container runtime to execute the containers, and it provides a command line interface to interact via the command line. Okay, so next slide.
Harsh, can you repeat the container runtime from that topic once again?
Okay, so Podman uses the runc container runtime. Runc is the name of the container runtime, and it is what basically container runtime does is it helps us to uh, manage the different containers which we are using on the that particular platform. Okay, so is that clear?
Yeah.
So next slide.
I don't want this guy, man.
What are daemons? Background processes.
घेऊन जा तू घेऊन जा इथं जिरून का आला होता का आला होता इथं
Shreyas, your mic
पूर्ण
is on. Will you please turn it off? Yeah.
And why Podman word occur? You will get to know in further slides. Gupta. Okay, so use cases of Podman. Like Podman is used in DevOps and CI/CD pipelines, which is continuous integration and continuous development. What is which means DevOps. Like it is useful for binding and testing the applications in automated workflows. And use cases, the other use case, and which is very much important, is security focused environments. So what happens is whenever we use Docker, so what we have to do is we have to give the root privileges to our container uh, to we have to give root privileges to a container so that it gets so that it is able to run itself. But Podman doesn't require any root privileges, which enhances another security layer. Like it doesn't give our container the root permission so that it changes like, or it does not have any access to the root privileges of our system. So this is the another advantage of using Podman over Docker. And multi-container applications suitable for managing complex applications composed of multiple containers. So in Podman, we have a term called pod, which is used to manage different containers, and which we'll see in the further slides. Okay, so these are the three main use cases of the Podman. So next slide. So why Podman? Like this answers Datta's question. Like first of all, daemonless operations. So what do you mean by daemonless operations? Does anyone know what is daemonless operations? I had mentioned previously. Can anyone explain in short? Okay, so I'll explain it again. Daemonless operations, it means like our container is not dependent on the any background service to run itself. Like in Docker, what happens is there is a background service called Docker which is running throughout the session, and which is responsible for creating and managing the container. So what happens is whenever you type any command, the command line goes and interacts with the daemon process, and then it creates a specific container or runs it. But in Podman, it isn't like that. What it does is it has its own container runtime, and it uses it to create and manage the containers. So what happens is this makes the Podman very lightweight, as it doesn't have to like interact with its background process to make or create or delete any containers, kill any containers in C. So this is what we mean by daemonless operations. The next is the enhanced security. So like I had also mentioned, like for using Podman, we don't have to give the container the root privileges of a system. Like for example, whenever we use a Docker, what we do is we use sudo docker and then type the command, specific command. So what we are doing is we are giving the root privileges of a system to that particular container so that it can have access to some extra resources and all. But in Podman, it is not required because like in Podman, we don't have to give the root privileges of our system. It enhance and due to this reason, it adds an extra security layer instead, and doesn't and our container doesn't have the like root permissions to hamper our system, or let's say anything like that. So this is the reason which enhances the security by using the Podman. And the next is the compatibility with Docker. Like if you use Podman, you will realize that all the commands are similar to Podman, and Podman is very much feasible with like you can pull the Docker images using Podman, and also pull and push the on the Docker hub. So this is compatibility with Docker. And the next is the support for pod-based workflows. So in Docker we have pod-based workflows. Like pods is nothing but having one or more containers running at a time, and you can manage them using shared resources among all those containers. So this is what we mean by pod based workflow. So this answers your question, Datta, right? These are the four main features why we should use Podman over Docker. Okay, so next slide. Okay, so talking about the Podman components. So first one is the Podman CLI. Podman gives us the command line interface to interact with the container runtime of our Podman. The next is the container runtime. Like I had previously mentioned, different runtimes like runc and cron are the container runtimes which are used in Podman. And also I've explained what is container runtimes. It is nothing but it is used to create and manage the different containers. And the next is the pods and the containers group. So like as I have mentioned, pods is nothing but managing a single or multiple containers together under shared resources. The next is the rootless and the rootful nodes. Like I have also mentioned this like in while using Podman, we don't have to give the root privileges of our system to the container, which enhances an extra security layer. And then comes the Podman image. Podman image consists of all the libraries and dependencies of Podman image consists of all the libraries and dependencies that we require to run an application. And the next is the Podman container. Podman container is nothing but a running instance of an Podman image. Like whenever we run a container, all the packages or dependencies gets installed, and then we use it to run in a container. So these are the components. Like I have covered them previously and right now again. Okay, so next slide. Okay, so the flow for building a Podman container is similar to as of a Docker container. Like whatever packages we write in a Docker file are when we first of all build out Podman image and then run it and put it in a container. So this is what the flow of a Podman container looks like. Okay, next slide. Okay, so moving for further to what are pods. So like I have mentioned what are pods. Like can someone put it in the chat box like what are pods? Yes, they are containers or a group of containers working together under a shared resources. So move further to the next slide. Okay, so this is how a architecture of a pods look like. So what happens in pods we run multiple containers under some shared resources. The shared resources are like as mentioned here: IPC, inter-process communications, networking, PID namespaces, C groups. So these are the different shared resources which are common to all the containers. So like pods is nothing but basically running multiple containers at a single time. So whenever we run a pod container, what happens is, first of all, by default, an infra container is created. What this infra container consists is, it consists of all the ports, networkings, and it contains all the informations of our containers or the containers which are going to be created in that particular pod. So infra container is by default created, and it holds the information of all the containers which are under that particular pod. And as you can see, like there are two containers here, container A and container B. And there's another layer called conmon is nothing but a C program. Like it is used to check if there's a change in the container, or like it is just used to check changes in that particular container. If there is a change, it gets detected using the common program. It is nothing but a C program. So this is what is meant by pods. And like pods is another feature which is like which is a like plus point in Podman over Docker. Like it helps us use multiple containers and shared resources between them, and which helps them to communicate into, like it helps the containers to communicate between them easily. So this is what why we use pods for. Okay, so next slide. Okay, so the next is Docker versus Podman. Like up till now we have completed what is Podman. So like, can someone tell me what all things have you like got to know about Podman? Okay, so I'll explain you once again in brief, like what all things we have learned up till now in Podman. So first of all, Podman is an alternative of Docker, which is used to like maintain and manage the containers, maintain and manage the containers. So what are these key features of Podman is that it runs in a daemonless mode, a daemonless architecture. Like it does not require any background process running to interact with it. It has a container runtime, and which is responsible for creating and managing the containers. So the next thing about Podman is that it doesn't require root privileges to run the containers. So what happens is when we don't give our containers the root privileges, like it doesn't have the it enhances the security. It adds a security layer to our application. Like and the container is not open to our system, and doesn't have any root privileges to access any of the resources which are not meant to be used. So this is what is an extra feature of Podman. And the next most important thing is pods. Like we use pods to like manage multiple containers at a time with shared resources. Like when we say multiple containers are managed at a time, what happens is they have some similarities. Like there can be similarity in network addresses, networking of that. Like let's suppose whenever we create a pod, and there are some containers inside that particular pod, all of them will be having same IP addresses, like they are sharing same network. So this is what is the feature of pods. Like we can use pods to share some resources between multiple containers. So this is what we mean by pods. Can Podman run in rootless with users from the remote auth system as they are not in the /etc/shadow? Yes, like Podman can run in rootless mode, like with users, even if they are not listed in the /etc/shadow file. This is one of the advantages of using Podman, like in rootless mode, as the non-root users can run the containers without needing the super user permission. Like they can run containers without needing any super user permission. And what is daemonless architecture? Daemonless architecture is nothing but it doesn't require any background process uh, to run its services. Like I have said previously, like Docker uses a background service named Docker which is responsible for creating and managing the containers. But it is not like that in Podman. Podman doesn't require any background service to be enabled. It uses its own container runtime. Okay, so moving further to Podman versus Docker. So the first of like, can you move to the previous slide, Vaishnavi? Okay. So first difference is the architecture. Uh, okay, so the first slide is the architecture. Like what is the difference between the architecture of the Docker and the Podman? Like I have said previously, like Docker uses a client server architecture. It relies on a daemon process, Docker that runs in the background and manages the containers. And the next is Podman. On the other hand, it uses a daemonless architecture. Like command directly communicates with the container engine, which makes it more lightweight. This is the reason which makes the Podman more lightweight, as it doesn't have to like communicate with the background service which is enabled, which is running. So yeah, this is the what is the main basic difference between the architecture of Docker and Podman. The next slide. Rootless operation. So like also I have mentioned this in my previous like slide. Like we don't need root permissions to run our Docker containers, but I mean Podman containers. But in Docker, we have to give root privileges to our container. This means that the non-root users need to use sudo to interact with the Docker. Like I had mentioned, like we use sudo first of all to give the permissions to the user to run a Docker container. But instead, in Podman, it isn't like that. We need not have to give the root permissions to our system, and this is what enhances the security of Podman. Okay, next slide. Next. Okay, so networking. Docker provides a built-in networking system that allows containers to communicate with each other and the outside one. Like it also supports various network plugins for more advanced networking configurations. But in Podman, it isn't like that. Podman leverages the host systems networking directly, which can simplify the networking configuration. Like it can also utilize plugins for more complex networking setups. So this is an advantage in Podman. Like the host systems networking directly, Podman leverages the host systems network directly. Okay, next. Operating system support. Yeah, one more thing which is like in Podman, Docker is like Docker can be used on Windows and Mac OS as well, and also on Linux distributions. But Podman is primarily focused on Linux system. So what would you do like if you have to use Podman on your Windows system? Can anyone tell me? What will you do like if you have to use Podman on your Windows system because it is not available on because it is only available on Linux systems? Yes, virtual machine. Has anyone heard about WSL? Okay, so can someone like what is the full form of WSL? Windows Subsystem for Linux. What do we do in WSL? Can anyone open their mic and tell me like what exactly it is? Okay, so I'll tell you like what WSL is. It stands for Subsystem for Linux. So what it does is like it provides us with a like compatibility layer to run Linux distribution natively on Windows. Like there have been two versions of WSL. The first one was WSL 1, where like all our Linux commands were translated into Windows, and then it would give the output according to that. But in the WSL 2, what it does is it provides us with a lightweight Linux kernel alongside our Windows application, so that we can run like Linux distros onto our Windows applications along with the Windows application running. So this is what we use WSL for. Like uh, we can use WSL to do things alongside with Windows and Linux. I mean Ubuntu or let's say any other distro simultaneously. So this is one of the methods where we can use Podman. I mean where we can use Podman using the WSL. So this is one of the key differences between Docker and Podman. Like Podman is available only on the Linux systems, and if you have to use it on Windows, then you can use WSL or virtual machine. I think WSL would be slower. Better to go with distros option. Yes, obviously. Like when we use WSL, there are some laggings in them. So when you go with the distros, it is obviously better. Like it is a lightweight Linux kernel. What WSL providing us, not the actual distro. So like the actual distros is always better. Okay, so now the further part will be covered by Vaishnavi.
Okay, so I think the containerization and the Podman part is completed. And now let us move toward the next part, that is the vagrant. So whenever you are trying to set up any virtual machine manually, what are the problems that you face is that you need to install all the OSs. It is actually very time consuming and it is also error prone. If you create any mistakes while configuring the settings of your virtual machine, then there might be errors and issues. Also, it is time consuming because manually setting up the virtual machine involves like various steps, which is going to consume a lot of your time. And it is also tough to replicate your virtual machines. And also, you will have to maintain the documentation for multi virtual machines, because if you are using different kind of virtual machines, you need to document how to duplicate them, what are their configurations, etc. How many of you have done GCCP recently? Yes. So if you have done GCP, then there was a task of creating a virtual machine. So you have created a virtual machine. You also know that you need to set up all the zones, the regions, the configuration of the system, the operating system that you require for the system, the storage or disk required for the systems. There are so many parameters that you need to specify, or when you are going to create a virtual machine manually. So this is very time consuming, and OS installation, it takes a lot of time. So here comes the option of Vagrant. So how Vagrant solve this issue is that you don't need to install the operating system basically when you're using Vagrant. You all might have heard of Docker Hub, right? Can somebody please on your mic and respond?
Yes.
Know about Docker Hub. Docker Hub has different images. So similarly, the case of Vagrants, we set up the virtual machine through Vagrant boxes. So as there are images in your Docker Hub, similarly we have Vagrant boxes in the Vagrant cloud. These Vagrant boxes are situated in Vagrant cloud. So how you pull the images from your Docker Hub, similarly you can pull the boxes from your Vagrant cloud, and this will automatically on its own set up the virtual machine for you. So how these virtual machines are set up is that they use the Vagrant file. Vagrant file is nothing but a file which contains all the configurations of your virtual machine, like the memory you require, the storage space you need, the number of cores you require for your machine, or the operating system that you're going to be needing. So let me just go to the Vagrant cloud. Okay, so this is the Vagrant cloud that you can see over here, and you can also see that it has lot of boxes. Like you have CentOS here, you have Ubuntu, you have Debian, Scotchbox, and lot of basically a lot of Vagrant boxes from which you can pull these boxes, and you can automatically set up your virtual machine. And when we want to configure any VMs, like if you want to scale up and replicate any VM, this process also becomes very easy through Vagrant file, because just we have to make the changes in the file itself, and the VM will automatically be updated. So let us see the working of the Vagrant. As you can see here, on your PC, firstly you will have to install the Vagrant software. So whenever you will install the Vagrant software and you go with a command that is called as Vagrant init, a Vagrant file will be created for you. This Vagrant file will have all the information about your virtual machine that you want to create, whether it be the box name is very important. It is like the compulsory parameter in your Vagrant file. It is the through box name that the Vagrant will actually identify which box you want to take from the Vagrant cloud. And the next thing are network in which you want to create your virtual machine, the memory or the CPU, its disk size. So basically all the configurations of the virtual machine that you want to set up are put in the Vagrant file. So the next task that you have to do is just run the Vagrant file. So when you will run this file, what it will do is that first the Vagrant will search for the virtual machine instance, similar virtual machine instance in your own PC. So if any similar virtual machine instance is already present in your PC, it will just run that instance. And if it is not present in your PC, then it will go to the Vagrant cloud and it will search for the box name that you have provided and it will apply all the configurations to it, and it will contact with the hypervisor and set up your virtual machine. So all the operating system installations that you have to do, all the manual configurations that you have to set up is not very required when you're using Vagrant. And the default hypervisor for Vagrant is Oracle VirtualBox, which is very quite popular. And through this workflow, Vagrant helps you set up many different virtual machines. So is this clear? Yes. So what Vagrant does is that basically reduces your time and okay, you want repetition. So I will explain you the workflow. So in your PC, you will be having your Vagrant software and you will also be having a Vagrant file. In this Vagrant file, you will be listing all the configurations of the virtual machine that you want to create, like what will be its network or its memory, its disk size or the storage that you need for your virtual machine, and what will be the box name of your virtual machine, which you are going to pull from the Vagrant cloud. So when you run this Vagrant file, it will first search if similar virtual machine is present in your PC. If it is present, then it will just replicate the similar virtual machine. And if it is not present, then it will go on the Vagrant cloud and search for the box which you have provided in your Vagrant file. And when it gets the box, it will contact with your hypervisor and automatically set up the virtual machine for you. So all the manual efforts that are required are very comparatively less in compared to when you do it manually. Is it fine? So let us see about basic commands that are used with Vagrants. The first command is Vagrant init. So what the Vagrant init does is that it will basically create a Vagrant file for you in which all the configurations, as I mentioned before also, are going to be present, which contains your box name. As I mentioned, it is a compulsory parameter, so that how you identify your image with the image name in the Docker Hub. Similarly, box name is very important to identify which distro or OS you want to use as your virtual machine. The second command is Vagrant up. So after using Vagrant init, you will create your it will create your Vagrant file. This file is also editable, so you can configure all the configurations according to your own needs. And when you will use the command Vagrant up, this file will run. So it will first search the virtual machine in provided with all the specifications in your local machine, and if it is not found, then it will pull the box from your cloud and set up the virtual machine. The next commands are vagrant halt, reload, or vagrant destroy. So as we know that if you want to change the configurations of a virtual machine, you need to set up everything again. But this is not the case in vagrant. In vagrant, you can just use the commands to reload your virtual machine or put it on a halt if there are not many users currently using your system and you don't need that virtual machine. Then you can put it on halt. And even if you don't need it at all, then you can completely destroy the virtual machine by using single command, and you don't have to completely create or change the configurations of the virtual machine again. And the next is the vagrant SSH. This is used to log into your different virtual machines that you have created. This basically creates a connection with your secure shell and helps you to navigate through the different virtual machines that you have created. Is the concept of vagrant clear? Can anybody tell me advantages that we have using vagrant? Yes, you don't need to install your operating systems again and again. Also, the errors that you might do are also minimized, and it is very easy because you are just changing the configurations in a file. If I first I was using 512 GB of 512 GB of memory, but I just want it of 128 GB. Then I just have to change the parameter, and I have to again run my Vagrant file, and it will automatically change the configurations of your virtual machine too. So using Vagrant, you can also experiment with different setups. You can also test very different types of configurations without affecting your main and actual system. And this can also help you to create stable development process. And as it was mentioned that Oracle VirtualBox is like the default hypervisor for your Vagrant, but you can also change the hypervisor from the Vagrant file. It for this session from our side. If you have any further doubts, you can just put them in the chat section or ask us.
Like for having GUI in the container, you need to use that kind of image, which has a GUI for itself.
Hello, am I audible? Okay, so I was having one question. Can you tell more about the structure of vagrant file and how is it created?
Okay, so we have to put up the like vagrant init command. It will create a vagrant file for you. In this vagrant file, we have you will have different configuration parameters, like what will be your box name. Like when you create like you have created a virtual machine using cloud. So similarly, all the parameters that are used in those are reflected in your vagrant file. And when you use create a vagrant init command, all the default parameters will be present. What is the box name you have to use, what should be the path of your vagrant file, or how much memory space you required for your vagrant file. This will default values will be present, and you can just customize it according to yourself, how you need in your VM.
Okay, and are the parameters are fixed file?
Yes, they are. Like you have a certain set of parameters in the file. You can just edit the parameters according to you. Like you can edit the values of the parameters, not the parameters.
Okay.
Not only creating OS and giving to the virtual, you can also use Vagrant to deploy your virtual machines on AWS and other cloud platforms also. And basically, if you are creating a lot of OS, you get a chance like to explore different types of systems, different types of configurations also without affecting your basic main system, and you can learn a lot from this. Does anybody else have any other questions? So I think that was all for this session, and we would surely like to see you in the further episodes of this and learn and explore DevOps in a whole lot depth. Thank you so much.